Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface, and this is just a quick tip about using the auto keyword in C++. So we know that all of the JNI types in C++ start with letter J, and we've seen that all the JNI types are defined in the JNI.h header file. So all types are defined in basically JNI.h header file. And then in C++ 11, they introduced the keyword auto, which is basically a system of type inference. So we don't need to specifically mention the name of the type, right? It's just we just put a keyword auto in front of it, and it automatically does the infers the type. And then we can take advantage of this auto keyword in JNI function calls. So when we're implementing a JNI function in C++, we can use the auto keyword. So if we don't want to worry about what is the type of this that the JVM is returning to us, we can just use the auto keyword. And then if we want to cache the, let's say, J class or J method ID or the J field ID, we can just put the static in front of auto. And this way we can locally cache them. So here's an example, a very simple example. This is my Java class person. It has a string name and int age, and then the constructor takes the name and age and constructs the object. And then I have overridden the toString method to just print out the information. And then in a test class, I create a native method, public static native person create person. So I send the Java string and Java integer to C++, and I want to return back to Java a person object. So if you look at the code, I mean, this is in the C++, we have a person class, JVM find class, because we need to somehow work with the person class, right? So we have to get a hold of the meta information of this particular class person. So we ask JVM to get us the class object, the J class or the meta information, which we already know it's the class path description. So package hierarchy / the class name. And we have already seen that if it's an inner class, then the outer class $inner class is the actual name of the class on the class path. And then here, instead of saying J class, I just say a static auto. So I'm caching this using the static keyword so that this person class gets defined and gets initialized only once. So this is the definition and initialization, and we know that the static variables get initialized only once in the entire lifetime of the function or of the program. So auto and then in order to create an object, we have seen that we should basically invoke the constructor, and the constructor is just the constructor is basically a special method which has the name init in diamond brackets, and then the signature of the method, which is the method parameter signature. In this case, it's a string and then an integer, and the return type of the constructor that we have seen that it's always void. Okay, we know that the constructor actually returns an object, but in the signature, the return type of the constructor as a method, it's always void. And then we ask JVM to create a new object for us. And again, I'm using the auto keyword here because the type here is J object. For the person class, the type is J class. For the constructor ID, for the method ID, the type is J method ID. And then for the object, the type is J object. But again, because the C++ has no problem with the type inference, then I just use auto keyword and don't concern myself with the actual type. But in this case, it's always best to have a very nice descriptive name for the variables. So constructor ID, this means this is the ID of a method. Constructor person class means this is a class meta information of the person class, person object, and person obj means this is an object instance of the person class. And then I'm returning the person object, which is the return type of this method, J object. All right. So the auto keyword, it just helps us quickly write the C++ code a little bit more easier, because we don't worry ourselves about the type of the variables. So let's head to Eclipse and try to just implement this and see how it works. So go back to the Eclipse, to my project. I'm going to create a new package called test25, and here I'm going to quickly create my person class. So person, and it has a string name and int age, and then constructor, and then it takes a string name and int age, and then we're going to assign them to our variables. This dot name is name, and then this dot age is age. All right, and I'm going to override the toString method just to have a to have a description of the object. All right, so this is our person class, very easy. And then I'm going to create a class to test this approach. So test auto, because I want to test the auto keyword in C++. So I'm going to create a method called test1, and the test1 is just public static void test1. And in test1 I want to create a person, so let's create a native method. Public static, I'm going to create it as a static method. Public static native person, the return type is person, and the name is create person. I'm going to send a Java string name and int age. Right, so this is a native, this is going to be implemented in C++. And then I'm going to say person create person, the name is Bob, and the age is 21. And then I'm going to do a sysout on person to just see that it has been successfully created. Now, because we have a native method in this class, we're going to run this class. We obviously need to also load the dynamic library into the memory. So system dot load library, and the name of the library is native_c. All right, and then I'm going to my C++ perspective. We select the Java file that has a native method. In this case, it's test auto, right? This one has this native method, and then we run our Java H tool on it, and it creates the header file, puts it in our header folder of the C++ project. So test25 test auto, right? It just has one native method, so we get one function prototype. And then we go to our src and then create a new source file, and let's call it auto_keyword.cpp. And the very first thing that we do, as always, we include the header file that we just created, test20 header, basically test25, and then we copy and paste the prototype of the function. So let's close the header file. The JNI environment pointer, I call it JVM. J class is the calling class, and it's the test auto. And I say test auto underscore class. It's a descriptive name. J string is name. I'm going to say it's a Java string, so J string J underscore name, and then J int, I'm going to say it's a Java integer, J age. And there is no need to do that, but it's a good practice to append all the Java types with or the Java variables with J underscore the actual name. So what I'm going to do, eventually I need to create a person, right? So what I need is to first of all get a hold of the meta information of this person. So I have to get the J class or the class information. So I say auto person underscore class is JVM find class, and then it's we have to specify it on the class path. So the class path for this person class is package is test25, and then the name is person. All right, so again, I'm using auto because I don't really care about the type. I don't want to bother with type writing the type, because it's very obvious what the type is, right? So I give a descriptive name to the variable, which is underscore class, and this means this is actually the class object, the meta information. And then I want to call the constructor. So again, I need to get a hold of the constructor method ID, constructor ID, JVM get method ID. And to refresh your memory, call to constructor is never static, so we never use get a static method ID. So for the constructor, it's always get method ID, and the return type in the signature is always void. So person class, and then the name is init, that's the name of the special method constructor, and the signature is signature of the parameters, and the return type is always void. And the signature is L semicolon for a Java object, which is a string and an integer, and the Java object is Java/lang/string. All right, So again, I'm using auto, and then if we want to call this method many times, so we can cache these two person class and basically the constructor ID. And then eventually I'm going to say auto person object is JVM new object. So create a new object for me, and then the class is person class, the method ID is constructor. And don't forget that we also have a vararg here, so we have to specify the actual values of the parameters, which is a string j underscore name and an integer j underscore age. And then I just return it back to Java person obj. So as you can see, the only we don't really care about these types, so we just use auto. It makes the code a little bit cleaner. So I could just write J class here, and then J method ID, and then here J object. But it's very easy to infer the type, so maybe it's easier in some cases to just write auto here. So if auto doesn't work for you, make sure that you go to your project settings, C++ build settings, and make sure that you set the standard to at least C++11. So if you go to the GCC C++ compiler on the dialect, you see I have set the language standard to the most recent one, C++1Y, which means the most recent C++ standard. So all I have to do now is to build the project, and as you can see, it builds fine. So let's copy and paste the dynamic library to Java. Paste, yes, and then go back to our test auto class and just run test1, which creates a person in C++ and sends it back to Java. So let's run this, and as you can see, we were able to successfully create this. I can create another person. So person2 is create person, and then let's call it James C++ and age 32, and do a sysout on person2. So let's see, the other person also gets created, and now the JVM crashed. That's very interesting. So the question is, why did the JVM crash? So we have this person, create person, James C++ 32, and then let's run this again. Okay, so why did the JVM crash? 32, 21. So we have the init. Okay, that's very interesting. Person, and then create person, James. Let's try with something else, right? 21. So why is it that the first one is getting created and the second one is not? James, okay, so it can create one person, but it cannot create the second one. Constructor ID, and then person. Test 21. So this code should work fine, but what we can do, we can actually change this back from auto to see if this is causing the problem. So J method ID, and then J object, constructor ID, and then person class, and then return J object. Okay, so let's build this again. It builds fine. Let's copy and paste the dynamic library, and in the test let's run this. So it seems to work fine. Let's see if we can create two objects. No, the creating the second object makes a problem, and let's see why. So the auto is not causing a problem. So integer v, and then the person, and then the constructor ID, new object, and then return person object. All right, so I'll leave it as an exercise to you to try to figure out what is wrong, and we'll look at the solution in the next lecture. So please stay tuned, and I'll see you in the next one.